hello everybody. Well, congratulations for not having any class today. That's good. However, just because we don't have class doesn't mean that we can't cover something. All right, so here's the deal with this one. I've had a couple of people over the last few days ask me about this particular problem that you're seeing on the screen right here. We go, just cover up all this other stuff. Okay, and there's been some confusion. So what I want to do is I want to take a few minutes to try and explain the concept of aliasing. And sorry, this is probably not going to be like a 2-minute explanation. I have a feeling it's going to take me at least a half an hour. Okay, so is it absolutely necessary that you see all of this? Well, if you want to understand what's going on in terms of aliasing, yeah, I actually do recommend that you do suffer through the half hour of what's going on here. I mean, there's kind of quick little shortcuts. Eventually, I will explain it, and you can probably use that shortcut most of the time. But I do want to actually give a full explanation about what's happening. All right, so here we go. First thing up is I am just going to run the application because the question is probably down to one of these MCQs where basically asked, okay, what is the value of X and what's the value of Y? All right, so here's the situation. When you run it, we end up with the following output. So here's the idea. X is a list containing Ali, a list 1, 2, 3, and the number 100. Y becomes a slice of the list, okay, so, and this of course means the first two items, because remember the 2 won't be included, so it would be just Ali and 1, 2, 3. Then suddenly we modify the first element of the list inside Y to be 9, and we modify the value of the first element of Y to be Adam. We print out X and Y, and you notice what happens is in the value of Y, we can definitely see the Adam, we can definitely see the 9. Okay, that's fine, that's not the issue. But then over here in the value of X, we'll notice that instead of Adam, we're seeing Ali, and instead of the original 1, 2, 3, now we have 1, 9, 3. Okay, so for this, we need to kind of go back and rethink some stuff. I'm going to call it almost from the beginning. I'm going to introduce one thing to you that we probably, I'm pretty sure I didn't see it in the slides anywhere, because I'm pretty sure I don't remember covering it in the lectures either. So although this is not really particularly part of the course for you to understand what's going on, maybe this will make some sense. All right, so here we go. So first of all, let me give you a very simple little program. There's nothing very funny about this, okay? It's just setting up a value of X and a Y, and if I print out the value X and I print out the value Y, there's nothing funny going on. It'll print 45 and 50. And since we're here, I'm going to say this. I'm going to say Y is equal to X, okay? And then I'm going to say X plus equals 10. And of course, if I run this program, which I guess what we'll do, there's nothing really surprising that's going to go on here, okay? So the value of X, of course, is the 55. The value of Y is the 45, which of course we picked up from before. Now, at this point here, what I really need to do is I need to start introducing a new piece of work. Okay, here we go. What I want to do is instead of printing the value of X, I want to print the value of the ID of X. Now, what the heck does this mean? All right, well, what this is, the ID of X is actually the memory location of the variable X. So this is the memory location somewhere inside the computer's memory. This is probably the address, and the value 45 is stored here. Okay, all right, so there we go. That's pretty simple. And what I want to do is I want to change my program a little bit, and I'm going to print the ID of Y. Okay, and I'm going to run this program, and I want you to take a look at the outputs. You see the value, or the memory location of X is given as this number, the memory location of Y is given as this number, and of course they are two completely different variables, so we expect them to live in different locations. Excellent, so there's no surprise here. Now, at this point here, I would like to introduce something different. I want to go back to this program right here. Okay, now remember we just discovered a second ago that, in fact, I'll close up this one. We just discovered a second ago that X and Y have different memory locations. Oh, and by the way, every time you run your program, your variables will probably have a different memory location, so never expect them to say the same thing. But I want to run this version of the program right now. So I'm going to print the memory location of X and the memory location of Y. Okay, and what I want you to do is I want you to look at the two values. Now, the actual meaning of the numbers is completely irrelevant, but if you notice, both X and Y have exactly the same memory location. Okay, so in the world of variables in Python, whenever you do an assignment operation, what happens is you will end up creating something called an alias. Okay, so an alias simply means that you have two variables using exactly the same memory location. Okay, why do they do this? Well, they do this in order to make things go really quick. Now, in the case of an integer, it's probably not going to save very much time, but you can imagine now if X was a really big list with a whole bunch of values, say 1,000,000 of them, when we do this aliasing, you can obviously make an alias very quick, but if you were to make a copy of it, well, then you'd have to copy 1,000,000 elements. All right, let me get back to this one for a second, because this is very, very strange that we've got here. And this happens to be the way that Python operates. So you see, if I run it again, hey, I still get the same addresses. They're different because every time I run the program, I'll get a different place. But what I want to do is I want to just do a small separator here, so just a small horizontal line. Here we go. And here's what I want to do. I want to say X is equal to X plus 10. So in other words, the value of X is changing by 10. And what I want to do is I want to print the ID of X and I want to print the ID of Y. So in other words, I want to print the memory location before and after the modification. Okay, now obviously we know what the value is. X will be 110, Y will be 100. That's not the problem. The thing that I'm interested in is what's the locations, and here we go. So take a look at this. Before we made the modification, the X and the Y lived in exactly the same spot. And that's, of course, exactly what we do here. But the more interesting one is when just after we've modified the value of X, you see what's happened is X now lives in a different place. That is because an integer in the world of Python is immutable. Okay, and of course, what that means is that you can't change it. Oh, well, wait a minute. If we can't change it, well, we just changed it right here. Well, unfortunately, the word immutable doesn't mean read only. What it means is that the value cannot be changed in place directly. And there's a whole bunch of reasons for this because of the way how integers are stored in Python. I don't want to get into it. That's more of an architecture thing. Okay, but the thing is that an integer is an immutable item, an immutable object, actually is the official word. And when I do something like X is equal to X plus 10, instead of going to the memory location and adding 10 to the variable, what Python has to do is has to make a brand new memory location with the new value, and then of course it will be modified. Okay, so there we go. That's sort of a background on what's happening. Oh, and what happens if I were to take Y and make it equal to, say, Y plus 1? Well, what we'd end up with, here, let me close this one up. Okay, and let's see what happens to the addresses. Yeah, well, they end up both changing. Okay, so that's no problem. So yeah, as you start to modify variables, you start to get different locations. Now, something that can be a little bit strange is I want to take the value Y and add 10 to it, because sometimes this can produce some really, really unexpected results. All right, and yeah, it has actually happened here. Take a look at what's happened. This is actually really, really bizarre. Okay, so initially, X had a value of 100 and I made an alias to Y, and so they both end up in the same location. I then modified the value of X, which gave me a new memory location, and I modified the value of Y to be the same value, and Python was smart and it said, well, you know what, I can save a little bit of storage if I reuse the same thing. And yeah, this type of thing is happening in the background all the time. It's done by Python to try and be a little bit more efficient. Okay, great. So now that's out of the way. That's for simple types. Now, I would like to repeat the same operation, but I would like to make, say, some lists. Okay, so here we go. Now, the first one I'm going to start with is I'm going to print the ID of X and I'm going to print the ID of Y. All right, now at this point right here, I don't believe that you're going to see anything really shocking. Yes, those are exactly the same memory locations. Okay, there's nothing strange going on here. However, here's what I want to do is I would like to, just after my separator, I'd like to take X at position 0, and I would like to make it equal to the value 10. Okay, so it's something different, and then I am going to print the ID of X, so memory location, and print the memory location of Y as well. All right, and let's run this one, and of course what you end up noticing is that, hey, they are still in the same location. Even though, I'm sorry, I should have printed this as well. Let's print X and let's print Y. Here we go. So there's one final thing. They will end up in the same memory location, even though, of course, you're changing one thing. Okay, now, here we go. Now, here's where things start to get a little bit more difficult to explain. First of all, why did the memory address not change? Okay, well, in the world of Python, lists are mutable. Okay, so mutable, not immutable, but mutable, which means that you can change the contents of the list without ending up with a brand new memory location. Okay, so you see, by making the change right here, I've changed something, but I have not changed the actual list itself. Okay, but I still managed to change things. Okay, what is going on? Okay, well, for this, I need to modify my program to be a little bit more detailed. So here's what I want to do. I would like to print the ID, or the memory location of X0, okay, ID of X1, and ID of X2. Okay, and I would also like to print the ID of X. So in other words, I want to look at absolutely everything. I want to look at everything for X, and of course I want to look at everything for Y. And give me a second, here we go. And I can see I've got something missing here, and this one here. Okay, and sorry, I shouldn't have removed that one. Okay, here we go. So there we go. That is a bunch of values. At this point, I would like to say X0 is equal to, I'm just going to make it 500. Okay, and I'm going to print exactly the same thing again. Okay, and we will print a separator between it, just kind of like the before and after. All right, so here we go. I want to run the application again because we need to take a look at a bunch of data now, because again, remember that the values are not important, but the fact that they're changing is kind of important. All right, so remember what this is. This is the memory location of X before, this is the memory location of Y before. They are, of course, aliased. The memory location of X and Y are exactly the same before and after. That's because we have a mutable list. But the interesting thing here is that after making the change to X0, you'll notice that both X0 and Y0's memory location have changed. That's because they both were referring to exactly the same memory location in the first place, and it was an immutable integer. And as a result, both got changed. Ooh. Okay, so a little bit on the tricky side, okay? But you see, now if I go one step further and make this kind of close to what I had before, let's just put A, B, and C in here, just so we have some different things. So now we have a list, and inside the list we have another list, and then we have some values. Remember that these are immutable objects, this is an immutable object, all of the same types of things. And what I'm going to do is I'm going to modify X's 1 at 2 is going to be set to the letter X. So I'm talking about modifying the value C to be X. Now, let's take a look at X and take a look at Y at the very end. So I'll just put a print, and we'll put some double lines here for a second. Okay, here's the first thing that I want to do is let's run it, and then we'll talk about the actual memory locations. All right, so here we go. Here's the output, and you can see what's happened is the value X has changed, of course, in both lists. So that's kind of suggesting some aliasing. Now, what I want you to take a look at is, you know what? I'm going to do one extra thing. X at 0 is going to be equal to 600. Okay, let's put it together as close as I can to that original question. Here we go. All right, so now let's take a look at what's happening. Remember, this is the before, this is the after, these are the values at the very end, and of course these are the memory locations and the first little bit. All right, first of all, you'll notice that X and Y are still at the same location, okay? That's from this one right here. We've got an alias. More importantly, you'll notice that, say, the before stuff, remember that this is the memory location of the number 1, this is the memory location of the list, this is the memory location of the value 3. And of course, the value of Y has exactly the same things. Whew. All right, after the modification, take a look at what's happened. We will notice that okay, so here we go. We changed the first value of X, but because it was a list immutable, both values ended up getting changed. So we ended up with a new location. But notice here in the second position, this was a list. Lists are mutable, therefore a new location is not required. Okay, so in other words, what's happening is when we have a list inside a list, we start to get this weird aliasing. Now, I know that this is not exactly the question that we had initially that I started with. The question that we had initially that I started with had list slicing. Okay, and this will be my final thing, okay, and this should hopefully explain all of the weird business that we just saw. Okay, so when you make a list slice, what you are doing is you are making a copy of the list. Now, what does it mean to make a copy of the list? Oh, and by the way, there are other ways to make a copy of the list. That is also one of them. Okay, but I don't want to do this one right now. I just want to do the list slicing because that is what we had a few seconds ago. When you make a list slice, you are making a new list. The items inside the list are copied. Okay. So what does this mean? Okay, no, sorry, I forgot I had to remove this value right here and this value right here, okay, because it doesn't exist anymore because there's only 2 items, so sorry about that. Here we go, we'll run it this time so we can take a look at it. So remember what happens. When you make a list slice, you are making a copy of the list. Okay, so first of all, you'll see that the list itself is in a different location. Therefore, it is a different list altogether. But what's inside the list is exactly the same. It's still a memory reference to that location. It's still a memory reference to this location. Okay, end of story. That's the before. After, remember there are 2 things that I did. I modified X at position 0. So in other words, I changed the thing that was right here, and you can tell that that is now a different memory location. That's because the thing at X0 was an immutable integer. Done. So it ended up in a new value. But you'll know that I also changed something inside this location, but because that was a mutable list, it means that I did not make a new copy. Okay, I changed what was inside the list, but this variable and this variable, of course, have not changed because it was a mutable list. The first value changed because it was a mutable integer. If it had been a string, it would have been exactly the same thing. Oh, okay, so now we're starting to get the idea about how much complexity is involved with mutable objects and aliasing. Okay, and yes, it really is kind of this unpleasant. Is it something that, do I wish that I had to cover this in this course? And the answer is no, I kind of wish that I didn't have to cover it. Some early programming languages, I really I didn't understand what they meant by it at the time, but the very first programming language that I learned was a programming language called Pascal. I'm not suggesting that it's a better language, but it was always described as being a teaching language. And one of the things that it did was it would not make aliases of things. And of course, when you're first learning how to program, if you just say, if you have two things up here, X and Y, you'd end up with 2 completely different things and they would be completely disassociated from each other. Because of course, during an initial programming course, it does make sense to have what I'm going to describe as easier languages, things that don't have this weird behavior going on in the background. Unfortunately, because we're trying to use sort of a language that's being heavily used by everybody, they are doing their best to try and keep the language fast and flexible, but unfortunately it comes at our expense in our 1201 course because it's a little bit harder to understand. Now, so what is the rule of thumb? Because obviously, I mean, printing out the IDs is kind of interesting, but do we really need to know this? And the answer is, well, no, kind of not really. Here's the rule of thumb, very, very simple. Whenever you have assignments of items, okay, or you have copies of things going on, basically anything simple gets copied. That's the easiest way to think about it. So think about this. Integers get copied, floats get copied, strings get copied. So floats, ints, strings, etc. All of these items get copied. Okay, and it doesn't matter if they're inside a list, it doesn't matter if they're inside a string, it doesn't matter if they're inside a dictionary or set or anything else, but I'm going to describe it as complex items get aliased. Okay, and what do I mean by complex items? I'm talking about lists, I'm talking about sets, I'm talking about dictionaries, I'm talking about, the immutable tuples. Ooh, well, immutable tuples are kind of like this weird thing because we already know that they're immutable, but here I will do one quick explanation of something about being immutable. All right, so here we go. So I guess one final thing. I don't know how long I've been, but I'm sure I've probably worn out my welcome already. But here we go. Let's have a tuple called A, and we'll put in the values 1, 2, 3, and we'll say that B is equal to A, and of course, if you print out A and you print out B, that's not a big surprise. If you print out the ID of A and you print out the ID of B, okay, well, before I click run, make your prediction, please, about what you think is going to happen. What do you expect for the memory location? Okay, I know you won't know the memory location, but will it be the same or will it be different? Okay, well, let's take a look. Okay, well, it is exactly the same. Okay, well, that's fine. That's nothing big surprise about this. Here, let's print a separator. Here we go. And let's start modifying it. Okay, so remember, well, A at 3 is equal to 50. Well, unfortunately, if you try running this thing, you get an exception because tuples do not support assignments. Okay, now, I mean, we kind of went and said they're immutable, but basically everything, they actually are immutable. It's just we can't modify them. All right, so here we go. But remember, just because it's immutable doesn't make it read-only. Okay, print A, print B, you just keep it exactly the same. Print the ID of A, print the ID of B. Here we go, and we run this one, and take a look at this. You see, the initial one before the separator, it was exactly the same. After the separator, I mean, I'm allowed to change the value of A. Immutable, the immutable thing doesn't say that it can't be changed. It's not read-only. It just means that you can't change the values inside. Okay, so by changing the overall tuple, well, I ended up with a brand new tuple. That's why I ended up with the new memory location, this one right here with the 4448. Okay, so it's a new memory location. So, sort of an unfortunate problem. You basically can't change what's inside, okay? But also the weird business is that integers are also immutable. It just happens to be that in the background there's a lot of weird stuff that's happening. And that's kind of the unfortunate thing. And as I say, it's unfortunate because if we're just trying to learn some basic programming skills about solving problems and setting up loops and putting things inside lists, we really don't need all of this weird complexity. However, we've got it covered now, and yeah, what I've covered here, will actually work its way back in, probably an earlier part of the course. I know it doesn't help you guys now, but at least it is explained. But really, it kind of goes back. It probably needs to go back somewhere around the place where we started to cover lists. But of course, unfortunately, by going and talking about it, we start to have to explain more stuff about architecture, and it detracts from what you would use lists for. That's the this problem that I have here with this. But in any case, here we go. That's kind of a very long-winded description about what was going on with that initial problem. As I say, if you simply follow the rules that I've marked down here and just keep these in mind, this is probably going to serve you pretty well for, I would say, just about any problem you'll run across. You don't really need to go and look at the IDs, but you can look at them to get an understanding about what's happening. But basically, simple items get copied, complex items get aliased. And if you keep those two things in mind, you're probably okay. And yes, if you have a list inside a list, there you go. You have yourself a pile of aliasing. If you have a set inside a list, or a list inside a set, or a dictionary inside a list, or a list inside a dictionary, yes, this is where all of your aliasing business is going to end up coming out.